Hello, let's continue our Sudoku adventure with Hey, What's New by SennyK. So this continues our irregular Sudoku theme week, and this one incorporates Heiawake, which is a pencil puzzle, into it. So pay attention to the rules. If you're familiar with Heiawake, that's helpful, but I will go over all of them. So we have irregular 6x6 Sudoku rules. So in each row, each column, and each bold outlined region, we're placing the digits 1 to 6 exactly once each. We also have Heiawake. We're going to be shading some cells. So I recommend using gray for shading. It's like pretending we're filling it in with a pencil. And you can use green for not shaded. I recommend that just because it's pretty consistent with other pencil puzzles. All right, so first of all, how are we shading? Well, there's rules about the shading. First of all, shaded cells can't share an edge. So I can't shade both of these because they would share an edge. That's not allowed. In addition to that, all of the unshaded cells need to end up fully connected to each other. So if I do something like this, and this is unshaded, then this unshaded can't get out. It can't connect orthogonally, it can't share an edge with any other unshaded cell. They have to be completely connected. You have to be able to path from one unshaded cell to any other unshaded cell, only going through edges. And so this wouldn't work. It's isolated. In addition to that, unshaded cells cannot go through more than 2 borders. So if these were all unshaded, I should say in a horizontal line or vertical, unbroken horizontal, unbroken vertical line. So this is an unbroken horizontal line of unshaded cells. And you'll notice it goes through 1 and then 2 borders. You cannot go through 2 or more borders. 0 or 1 is all that's allowed. And so that would be disallowed. We'd have to shade something to prevent that from happening, like maybe this one. These go through 1 border, this goes through none. All right, so those are the shading rules, but we need to connect that to numbers. So that's where these squares and circles come in. That also helps kickstart our shading as well. So circles count the number of shaded cells in the region. So if this was, say, a 2, there might be 2 of them shaded and the rest unshaded. This region goes up to here. So a 2 would mean that. Now, the squares are unshaded. They count the number of unshaded cells. So if this was, say, a 4, then we might have, I don't know, these, I guess I should say these unshaded and then these 2 shaded. So it's kind of the inverse. We're either counting the shaded cells or the unshaded cells in that region. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. So the first thing I noticed is that these 2 cells are both the circle and the square. So in order for the same digit to count the number of shaded cells and the number of unshaded cells, they just have to be a 3. Because 6 over 2 is 3. So because there's 6 cells in the region. Now, this is a classic Heiawake kind of intro trick, which is in order to shade 3 cells, I'm either going to be doing this so that they don't touch, or I'm going to be doing this so they don't touch. You can barely do 3 cells. A nice little trick of analysis you can do is if you can highlight 2 cells that share an edge, you know they have at most 1 shaded in them. So this has at most 1 shaded, this has at most 1 shaded, and this has at most 1 shaded, which means they all need 1 shaded in them. And we're going to have to interleave so that we don't touch like this, right? We're going to have to go back and forth. But there's a problem with doing this, which is that this is unshaded, and it can't get out anywhere. It can't connect to all the other unshadeds. So we've immediately broken the puzzle if we do that. So we're going to shade these 3, and we're going to carefully look at every cell that directly touches those, and we're going to unshade them. Now, when we do that, we want to be very careful that we remember the connectivity rule and the don't go through 2 border rule, because we just got a bunch of unshaded cells. So this needs to connect to all the other unshaded. So it's got to continue to here. But then this clump here of unshaded still isn't connected to everything, and it's only got one way out right here. So that's also unshaded. And then down here, this one has to connect down here. This has a few options for how it's going to grow. This one has to connect out here. And so now we know this counts the unshaded, so we know it's a 5 or a 6. All right. Now, anything else come out of that? Yeah, this goes through 1. It can't go through a 3rd, so this is going to be shaded. It's going to be surrounded by unshadeds. This goes through 1, but it could go through 1 more because this isn't a region border. this is already 4. So this is 4 or 5. This is shaded, so it's not going to be a 6. Shaded or unshaded? Not sure. I don't think shading it breaks anything, does it? All right, what else can I do here? This goes through 1, so this has to be shaded. I guess I should note that this square and this circle are in the same region, so they're going to add to 6. And so it's going to be 1, 5, or 2, 4. Same thing here, 1, 2, 4, 5. All right. We already have 2 unshadeds in this region. So the square is not going to be 1. It's 2, 4, or 5, which means this one's not 5. Tiny deductions. This has to be unshaded because it's next to a shaded. Now, this clump here still has to get out, either here or here. What else can we say? There's probably a connectivity thing or a cell border crossing or region border crossing. Yeah, here. This crosses 1. It can't cross another one, so that's shaded. And it's surrounded by unshadeds. Did that do anything? Well, it affects these counts, right? Does it? Yeah, we have 3 unshadeds in here, so that's not 2 and that's not 4. And so we're gonna have to unshade at least one more of these, but I'm not sure which. I guess I should note there's some irregular Sudoku logic here, which is where does the 3 go in this column? Well, it can't repeat in this region, so it's going to end up right here. What if we can do more with 3s? Yeah, this 3 sees all of these in this region, so this has to be a 3. And then these aren't 3, that's not 3. What about this region? This 3 looks in, this 3 sees here, this 3 sees here, so that's a 3. And now none of these are 3s, so that's a 3, and we're done with 3s. Okay. We get through 2 3s in a corner. Nice. All right, what else can we do? How about we need 3 shadeds in this region. Notice this can be max 1, this can be max 1. So we need to put 1 here. That means this guy can't connect this way, so it's going to have to connect this way. And that makes this a 5. All right. I will note that these 2 digits are the same as these 2 digits, but that doesn't mean the 5 goes here. This could be a 5, and this could be 4 with that being a 4. But the reason these 2 digits go here is because we're comparing the row to this region. They share these 4 cells, and they have 1 of each of 1 to 6, and so these 2 are the ones these 4 aren't, and these 2 are the ones these 4 aren't. So they're the same digits. Just maybe in different order, though. Okay, so what just happened here? We have 1 in here and 1 in here. Can I do more of that? Oh, this has to get out. So this is going to be shaded and that's going to be shaded in order to do 3. This has to be unshaded because it's next to a shaded. So now we have 4 unshadeds. Does it go to 5? I don't know yet. Oh, and this has to be unshaded and that has to be unshaded because we shaded this one. So it is a 5. So that's 5, that's 1. So we don't know what this is, but it's the same. Okay. This one has to get out. It's surrounded by shadeds. And this still has to get out. So we're up to 4 unshadeds here. So we can adjust these numbers, 4, 5, and 1, 2. All right. So we're down to these. Which one's shaded? Any of them. Okay. So if I were to shade this one, that would mean this is a 5 because we're counting 5 unshadeds, which forces this to be a 4. And if this is a 4, it also has to be shaded in order to have 4 unshadeds. If it was unshaded, it would be a 5. But the problem is that that's now 2 shadeds touching each other. That's a pretty fun step. So this one can't be shaded is the conclusion, making this a 6. And now this whole column already passes through one border. It can't pass through another, so that's shaded. Which does make this a 4 and a 2. Okay. All the circles are filled. All the shading is done. Hopefully it's correct. So it should just be Sudoku from here. Irregular Sudoku. All right, let's do it. Where do I want to get started? Is there like an obvious place? I mean, these are 2, 4, 6. Oh, this can't be a 4 or a 6. So that's our 2. Okay. So this is a triple for the region. It's 1, 4, 5. It's not a 4. In fact, we need a 5 in this column. That's 5. That's 1. These are not that. Okay, so this is a pair then for the row. It's a 2 and a 6. Okay. In fact, this is 2, 4, 6. That one's not 6. This is 1, 5, 6. This can't be 1, 5, so that's a 6. Placing the 6 here. That's a 2. 2, 4 pair. So what's left? 1, 5. I don't think it's... oh, it is resolved. That 5 looks down. So that's 1. That's 5. So this is also 2, 4. Got a lot of 2, 4 pairs coming up. This is a 2, 4 pair. So this is 1, 5, 6. That's not 5. Okay, so where's the 2 in this region? It's one of these two. Actually, it's placed. It's here. That gives us 4 and 2 and 4 and 2. 1, 4, 5, 6. This isn't 6. It's 1, 4, 5. It's not a 4 either. Oh, this should be done for the region. This is a 6. That gives us 1 and 5 and 6 and 4. That's a 1 and 4. It's actually kind of hard to scan the regions because the coloring doesn't match up with them. This is a 4 and this is a 1, and we're done. All right, cool puzzle, Senny. I liked this last step here for the shading, like how the Sudoku actually came into play to finish the shading off. But it did feel like we were kind of solving a Heiawake and then on top of that solving a Sudoku. But that tends to happen with these kinds of hybrids. All right, well, how'd you do?